Welcome to the AI Built Right podcast. Emily is an AI architect guiding businesses in scalable AI solutions. Today, with Michael, an expert in AI strategy, explore fine tuning strategies, LoRA, QLoRA, and full fine tuning. Discover how to optimize performance in production systems. Dive deeper into AI at AI Built Right podcast. Choosing the right fine-tuning strategy can be quite challenging, especially when balancing cost and performance. Let's dive into the intricacies of LoRA, QLoRA, and full fine-tuning. Michael, what are your initial thoughts on these methods?
Great question. Each method has its unique strengths. Low RA, for instance, is fantastic for scenarios where you need to keep the computational cost low while still achieving a
Absolutely, it's
reasonable
quite
performance
efficient.
boost.
And then there's QLoRA, which seems to strike a balance between precision and resource usage. It's like the middle ground between low RA and full fine-tuning. How do you see its role in the cost-performance metrics?
QLoRA is particularly useful when you're targeting a specific performance level, but can't afford a full-scale fine-tuning operation. It optimizes resource allocation while still
That's a
advancing
critical
model
point.
accuracy.
Now, full fine-tuning is often the go-to for maximum performance, but the costs can be prohibitive. What scenarios make it the best choice despite these costs?
Full fine-tuning is ideal when precision and customization are non-negotiable, like in high-stakes applications such as medical or legal fields. The investment in resources translates into unparalleled
That's
specificity
definitely
and
where it
control
shines.
over the model.
Absolutely, but let's talk about combining these methods. Are there scenarios where a hybrid approach might be beneficial?
Combining methods can be very strategic. For instance, starting with low RA for initial training to keep costs low, and then moving to Q low RA or full fine-tuning for critical deployments allows for
That's a smart
flexibility and
approach.
scalability.
It's interesting how these strategies can be layered. But what about the potential drawbacks? Are there risks involved in mixing strategies?
Mixing strategies can introduce complexity, especially in maintaining consistency across different phases of model development. There's also the risk of resource bottlenecks if not
That makes
carefully
sense.
managed.
Managing these complexities is crucial. So when it comes to production systems, how do you decide which strategy to prioritize?
It boils down to the specific goals of the system. If rapid deployment and low cost are priorities, low RA or Q low RA may be favored. For long-term, high-performance systems, investing in full fine-tuning pays off.
That sounds like a pragmatic approach. How do these strategies influence the lifecycle management of a model?
Lifestyle management becomes more dynamic. You might start with low RA for rapid prototyping and later switch to full fine-tuning as the model matures
That's a
and
great way
its
to
role
evolve.
expands.
Evolving the strategy with the model's life cycle is insightful. Could you share an example where this approach has been effectively implemented?
Certainly, in the finance sector, initial models might use low RA for sentiment analysis. As the system grows, Q low RA or full fine-tuning can refine the model to handle complex predictive tasks.
That's a fantastic use case. It highlights the adaptability of these strategies. What are the key metrics you would track when evaluating the success of a chosen strategy?
Key metrics include accuracy, computational efficiency, and resource utilization. Additionally, monitoring model drift and adaptability over time ensures
Those are
the
crucial
strategy remains
metrics.
effective.
Indeed, keeping an eye on model drift is essential. How important is it to involve stakeholders when selecting a fine-tuning strategy?
Stakeholder involvement is critical. Their input ensures the strategy aligns with business goals and operational constraints. It also helps in setting realistic expectations.
Aligning with business goals is key. How do you handle situations where stakeholders' expectations might not match the technical realities?
Clear communication is vital. Educating stakeholders about the technical limitations and potential trade-offs helps in managing expectations
Communication
and
is
fostering
everything.
collaboration.
Absolutely. Open dialogue is crucial. When you look at the future of fine-tuning strategies, what trends do you see emerging?
We're likely to see more automated and adaptive fine-tuning processes, leveraging AI to dynamically adjust strategies based on real-time data and performance feedback.
Adaptive fine-tuning sounds promising. How might this impact the role of human experts in the loop?
Human expertise will shift towards oversight and strategic decision-making, ensuring AI-driven adjustments align with broader
That's an
objectives and
exciting
ethical
shift.
standards.
It's fascinating how technology evolves roles rather than replaces them. As we wrap up this part of our discussion, what advice would you give to organizations just beginning their fine-tuning journey?
Start small, prioritize learning, and be ready to iterate. Understand that the first strategy might not be perfect, but each step will provide valuable insights for refining your approach.
Iterative learning is so important. As we continue our discussion, let's explore some case studies where these strategies have been applied successfully.
That sounds great. Examine real-world applications can provide practical insights into how these strategies play out and what lessons can be applied elsewhere.
In one of the more compelling case studies I came across, a company used QLoRA to optimize their NLP model. They initially used full fine-tuning, but the computational costs were through the roof.
QLoRA can be a game changer in such scenarios. It retains the performance benefits of full fine-tuning, but at a fraction of the cost. It's particularly effective when you need to scale quickly
Exactly, that's
without
a huge
compromising on
advantage.
quality.
Another example was from a team that used LoRA for a recommendation system. They had very specific domain data and needed a targeted approach.
Low R is often ideal for such targeted tasks. It allows for efficient adaptation to niche datasets without the overhead of full fine-tuning. Plus, it integrates seamlessly into existing pipelines.
What about combining these strategies? Have you seen any cases where hybrid approaches were particularly effective?
Combining strategies can yield significant benefits. For instance, using low RA for initial fine-tuning and then applying QLow RA for further optimization can balance both cost and performance
That's a
exceptionally
smart
well.
approach. I can see how that would provide a robust solution. It offers flexibility to adapt as the model's needs evolve.
Absolutely. Flexibility is critical, especially in production environments where requirements can change rapidly. This hybrid strategy allows for iterative improvements without extensive downtime.
Speaking of production environments, how do you measure the success of these strategies? What metrics should teams focus on?
Performance metrics like accuracy and F1 score are crucial, but also consider operational metrics such as latency and throughput. Cost efficiency and scalability
It's a
should
comprehensive
always
view,
be in the
indeed.
equation.
It's clear that these fine-tuning strategies offer a spectrum of options. The key is aligning them with your specific goals and constraints.
Precisely. Effective strategy selection is about making informed decisions based on your unique context, whether it's cost constraints, performance targets, or both.
Before we wrap up, any final thoughts on how teams can better prepare for implementing these fine-tuning strategies?
I would advise teams to invest in continuous learning and stay updated with the latest advancements. The field is evolving
Absolutely.
rapidly, and
Continuous
staying
learning is
informed is
vital.
crucial.
Thank you so much for sharing your insights, Michael. It's been a fascinating discussion.
Thank you, Emily. It's been a pleasure discussing these strategies with you. For our listeners, if you want to delve deeper into these topics, tune into the AI Built Right podcast.
As we wrap up, I'm curious about your thoughts on the cost implications of these fine-tuning strategies. How should teams balance their budgets with the need for high performance?
Great question. Cost is indeed a critical factor. You generally see that low RA and Q low RA are more cost effective compared to full fine tuning, primarily because they require fewer computational resources. However, the trade-off is in the level of precision and customization you can achieve.
Right?
Uh,
Balancing those elements is key.
uh,
And that's where the performance metrics comes in, right? Weighing those cost savings against the potential benefits in the model's output. Now,
exactly. The performance matrix helps outline which aspects are most critical for your project. For projects that demand high precision, investing in full fine-tuning might be justified. But for others where speed and cost are priorities, low RA or Q low RA could be more suitable.
so what about combining these methods? Have you seen successful implementations where teams use a hybrid approach?
Yes, combining methods can be very effective. A hybrid approach often leverages low RA for parts of the model that don't require intense customization, while using full fine-tuning on sections where precision is crucial. This can optimize both
That makes a lot
cost
of
and
sense.
performance.
And I imagine the context of the application plays a significant role in deciding the strategy. Some industries might prioritize different elements of the matrix.
Absolutely. For instance, healthcare applications might prioritize precision and data privacy, leading to a heavier reliance on full fine-tuning. On the other hand, industries like retail might focus more on speed and cost efficiency.
That really illustrates how the one-size-fits-all approach doesn't work here. Tailoring strategies to specific needs is crucial.
Precisely. It's all about aligning the fine-tuning strategy with the business objectives and technical constraints of the project. This ensures the best possible outcome.
Before we conclude, any last tips for teams looking to optimize their fine-tuning strategies?
I would suggest starting with a clear understanding of your goals and constraints. Conducting pilot studies can also provide valuable insights before committing to a full-scale implementation.
Great advice. This discussion has certainly provided a lot of food for thought. Thank you again, Michael, for joining us today and sharing your expertise.
Thank you, Emily. It's been a pleasure to discuss these critical strategies. For listeners interested in more insights, don't forget to check out the AI Built Right podcast.